Hello everyone, welcome back to the channel. Today we are going to continue learning matrix in Python. So let's start with the transpose of a matrix. So at first let us consider a random matrix. For example, it can be 5, 6 and 7, 8. And then we'll create one another matrix named as B, which will be a 0 matrix initially, and then we will add the value of the transpose of A to it, so that the B can be the transpose of A. So what the concept here is that the number of rows of matrix A should be the number of columns of matrix B, and the number of columns of matrix A should be the number of rows of matrix B. Because if for example here A is 2 cross 2, so B will also be 2 cross 2, but if A would be 3 cross 2, then B should be 2 cross 3. So the number of rows and columns should be interchanged. So for that we will write here np.zeros, that is, it is a 0 matrix, and then we will write here the dimensions. So length of A with index 0, comma, length of A. Okay, and then we will use the for loop for I in range length of A, and then for j in range length of A with index 0. So here we are writing bji is equal to aij. So the I and j element should be interchanged to make it transpose. So bji will be equal to aij, and then we can print both A also and B also. Print A, print B. So this program will work for any order of matrix. So here if we would have taken it 3 cross 2 or 2 cross 3 any, then it would work, because this is a generalized way or the logic behind taking out the transpose of a matrix. Okay, so let us run this. So here you can see this is matrix A and this is matrix B. So we can even say A to be printed in this manner. How? Instead of writing print A, what can be written is, you can write here, for row in A, print row. So let us run this again, and you can see now it is printed in the same format, and between them we can leave one line. Now it's correct, and you can see this is matrix A and this is matrix B, which is the reciprocal of A. So it is like this 5, 6, 7, 8, and it will be 5, 6, 7, 8. So rows and columns are interchanged. Okay, so let's move forward, and now let us see some shortcuts using the NumPy library to do operations on the matrices. So using NumPy methods. So we have already imported NumPy in the file above. Now let us start with some new matrices. I think, yeah, I have commented this. Okay, so let us make a new matrix. X is equals to np.array, and then 1, 2, and then 4, 5. We'll just copy this and paste it here. We'll write y equals to np.array, and here we can write 7, 8, 9, 10. Okay, now let us start with adding the matrices. So if we want to add, then we can simply print np.add. So this is a method of NumPy library, so we can just write np.add, x comma y. So let us run this program and see. So you can even print this matrices. So printing x and print y, and here you go. So 1 plus 7 is 8, 4 plus 9 is 13, 2 plus 8 is 10, and 5 plus 10 is 15. So it's correct, and you can see the addition of the matrices here of both the matrices. Okay. Now if you wanna subtract, then what we will be doing is we'll just print np dot subtract x comma y. So let us run this and see. You can see the subtraction 1 minus 7 is minus 6, and all other are also correct. So this is the subtraction of the matrices. Now if you want to divide, we can use np dot divide. If you want to multiply, we can use np dot multiply, and we can try this here. Now also like divide, sorry, this should be copy. So this will be divide, and for multiply, just write multiply. So here multiply means element wise multiplication, and division also means element wise division. So you can see here it's divided, and here it's divided again because I haven't changed this multiply. Okay, so here it's multiplied and here it's divided. Next comes if you want to multiply matrices, not element wise, but you need to multiply the whole matrix. Then what? So this was multiply element wise, so it was element wise multiplication. And if you want to multiply the whole matrices, then we can use dot. So here instead of divide, it will be dot. Let us run and see. You can see we got a different answer in multiply and dot. In dot, the whole matrices are multiplied. For example, 1 comma 2, 1 into 7 plus 2 into 9. So that is 7 plus 18, and which is equal to 25. So you can see here. Whereas this element wise multiplication was 1 into 7, which is 7. Okay, so next is square root. So square root, and for this we just gonna write sqrt. So it will calculate the square root. Let us write one more and then we will see the result. So if you want to print the summation of all elements of a matrix, so summation of all elements of a matrix, then what are we gonna write is we will write here sum. So let's do one thing, let us comment these. Okay, and now let us see for the square root and the summation of all matrices. There is some problem. Okay, it will not be of two matrices, instead it will only of one matrix. Summation of all elements of a matrix, as I already said, a matrix. So just calculate of one matrix. Square root will also be of one matrix only, of course. Okay, so you can see this is summation like this: 4 plus 1 plus 2 plus 5, which is 12, and this is matrix B, and this is the square root of matrix A. Okay, now the next thing is if we want to print the summation of each column of matrices. Here it was elements. Now if you want to print for each column, So for that we will print np dot sum, and then we will write y comma x y, because we want for y matrix this time we can even write x, and then x is 0. Just simply writing x is 0 is enough for the column addition. Okay, there is a parenthesis missing, and let's go it again. So you can see column wise addition is here, like 7 plus 9 16, 10 plus 8 is 18. Okay, so next thing, if you want to print the summation of each row of matrix, then so it's pretty simple, as we have learned column also. Okay, so each row of a matrix is simply axis is equal to 1. Let us go, and so these are two different matrices, so you can just print like this so that there is some gap between it. Now you can see this one is column wise, as we have already discussed, and this one is row wise, like 7 plus 8, 10 plus 9, like this. Now if you want to transpose the matrix, there's a shortcut for that, although the logic should be known, and that's why we had discussed it at the very first of the video. So for the transport, you just write x dot t, and again, or we can just comment this. And now let us save and run. You can see this is the transpose of this matrix. The rows are the columns here. So thanks for watching. This was all for this video. Do hit the like button and subscribe to the channel for more coding content. Happy coding!